All right, let's jump right in. Today, we're cracking open a programmer's toolkit. This isn't just any toolkit. It's the one that powers everything from your favorite websites to the absolute cutting edge of AI. We're talking about Python, and we're going to break down the core building blocks that make it all tick. So let's start with a really big question. How do you actually teach a computer to think? I mean, really, how do you tell a machine what to do, how to react, how to make a decision? It's not magic, not at all. It's all about learning to give it a super precise set of instructions. And that's exactly what we're here to figure out. And to give those instructions, you need a language, something that both you and the computer can understand. Now, there are a ton of programming languages out there, but Python has just exploded in popularity. Why? Well, because it's seriously powerful, but it's also really clean and easy to read. It's the perfect place to start. So let's dive in. Think of it like cooking. Before you can make some amazing dish, you've got to know your basic ingredients. It's the same with code. These are the absolute essentials that everything else is built on. And the most fundamental ingredient of all is the variable. Seriously, the best way to think of it is just a labeled box. You can slap a label on it, like age, and then you can pop a piece of information inside, like the number 30. Now, whenever your program needs to know the age, boom, it just looks for that box. It's that simple. It's how programs remember things. But you can't just name these boxes whatever you feel like. Python has a few simple but absolutely crucial rules. As you can see here, names can have letters, numbers, and underscores, but they can't start with a number. That's a big one. And you have to be careful with capitalization. Age with a lowercase a and age with a capital A are seen as two completely different boxes to Python. So what kind of stuff can we actually put in our boxes? Well, the information comes in a few basic flavors, or as they're officially called, data types. You've got integers, which are just whole numbers. Floats, for any number with a decimal point. Strings, which is just a fancy word for text. And booleans, which are super simple. They can only be true or false. That's it. Okay, so if variables are our nouns, the things, and data types are kind of like our adjectives describing them, we're still missing something, right? We need action. We need verbs. And in Python, our verbs are called operators. Operators are what let us actually do things with all our data. We've got arithmetic operators for all the math stuff, like adding and subtracting. Then we have comparison operators to check things, like, hey, is this score greater than or equal to 75? And we've got logical operators to combine these checks, like, is the user logged in and are they an admin? So now that we have our data and our operators, we can start putting them together to give our programs some brains. This is where the real magic happens. We can teach the computer how to make decisions and react differently based on the situation. Let's just walk through this example right here. The score is 85. First, the code checks. Is 85 greater than 90? Nope. Okay, so it moves on to the next check. Is 85 greater than 75? Yes, it is. So it runs the code to print grade B. And then, and this is super important, it completely skips the rest of the block. It found its answer, it did its job, and it's done. Now that if, elif, else structure is awesome for all sorts of complex logic. But what if you're just checking one thing against a bunch of specific values? You know, like if the user's choice is A, do this. If it's B, do that. For those cleaner cases, Python has something called match case. It's not as flexible, but boy, can it make your code a lot easier to read sometimes. Decision-making is great, but what about doing things over and over again? What if you need to perform the exact same action 100 times or 1,000? I mean, can you imagine trying to write that out line by line? It would be an absolute nightmare. Thankfully, there is a much more elegant way. It's called a loop. A for loop, for example, is literally designed to repeat an action, either for a set number of times or for every single item in a list. Instead of writing the same code again and again, you write it once, inside the loop, and let the computer do the boring repetitive work. This is a total game changer. Okay, so we've got data, we've got logic, and we've got loops. That's a great start. But as our programs get bigger and bigger, how do we stop our code from becoming a giant tangled mess? Well, the key is organization, and we do that by building reusable blocks. And we do this using functions. A function is basically a named chunk of code that does one specific thing. The recipe analogy is perfect here. You write the recipe once, give it a name like calculate tax, and then anytime you need to calculate tax, you just call the recipe by its name instead of writing out all the steps every single time. It's all about writing code once and using it forever. And, Python is all about being clean and efficient. Check this out. For a simple task, you could write a standard function, like you see on the left. But for really simple one-off operations, Python gives you this cool shortcut called a lambda function. It lets you take that whole chunk of code on the left and squash it down into a single, elegant line. Same result, just way less typing. So we've seen how to organize bits of code into functions, but to build truly complex, real-world apps, we need an even bigger, more powerful way to think about our code. And this is where we enter the world of object-oriented programming. And trust me, this changes everything. The core idea here is to model real-world things right in your code. You start with a class, which is basically a blueprint. It defines all the properties and abilities of some type of thing. So you might have a car blueprint. Then, from that blueprint, you can create actual individual objects. So the car class is the blueprint, but a specific red Tesla you create from it, that's an object. Now, this whole approach is built on a few really smart principles. The first is called encapsulation. This just means we bundle the data, like a car's color and speed, and the functions that use that data, like accelerate, together inside the object, kind of like a protective capsule. This is so important because it stops other parts of your program from messing with that data directly, which helps prevent all sorts of weird bugs. Next up, we have inheritance. This is an incredibly powerful way to reuse code. You can create a new class that's a more specific version of another one. For example, you could have an electric car class that inherits everything from the main car class. So you get all the normal car stuff for free, and you just have to add the unique new things, like a charge battery method. You don't have to start from scratch. And finally, we have polymorphism. Okay, I know it sounds super complicated, but the name literally just means many forms. And the idea is actually pretty simple. It's the ability to have one single action, one method, that behaves differently depending on the object you're using it with. It makes your code incredibly flexible, and the next slide has a perfect example. See, this makes it so clear. Imagine you have a dog object and a cat object. They can both have a method called speak. But when you tell the dog object to speak, it barks. When you tell the cat object to speak, it meows. You're calling the exact same action, speak, but you get a different, totally appropriate result for each object. That right there is polymorphism. Same action, different result. And there you have it. Variables to hold data, operators to take action, loops and conditionals for logic, functions to stay organized, and classes and objects to build entire worlds. You now have the fundamental toolkit of a Python programmer. So, the only real question left is, what are you going to build first?